So now I've got the guts out of the that ionizer demo unit, and just playing around with the flybacks. They're pretty tiny flybacks, admittedly, so I'm not getting too much out of it. Tiny little arc. Let's see if I can focus on it. It's not much going on there, but it's kind of fun. Very high pitched. You can actually there's this little potentiometer there that you can vary the frequency. I don't know what the values are, but I mean it's a 100K resistor, or variable resistor. So, but I don't know what that translates to in frequency. I haven't really investigated the circuitry much, so I'm not really too sure what's going on there. But let me see if I can put these guys in parallel, get a little more current, maybe get a little bit more beefier arc out of there. So I've got these hooked up in parallel now. Unfortunately, the second flyback doesn't really bring much to the party. You can see this is about all it's got. Just a tiny little current. So you know, if I switch on the other one, you can see the difference. So yeah. Yeah, this is actually a different model, or at least I don't know if this is the model number. I googled this and I didn't really get much. It's KBTG04B01. There's the date code, April 2007, I'm guessing, or maybe the 4th week of 2007. I don't know. Yeah, this other one is a KBTG03Z B01. So I don't know if that's a manufacturer's part number or just a proprietary part number for the company that built this. And also on this one, you can see there's a little air gap in the core there. That probably has something to do with it too. They look pretty similar. I don't know what that sealant stuff on there is for. Yeah, they look pretty similar, but that's obviously a different, lower output. One is designed to drive the little antenna, and one is designed to drive the needle that I've now got on the end of this chicken stick, I guess. So yeah, it's I probably won't end up using this one. I don't feel like modifying it. I've got a collection of flybacks out in the garage. If I do want to do anything high voltage with some flybacks, I'll certainly opt for those. They're proper flybacks out of televisions, old large CRTs and stuff. So I just thought it might be cool to have this thing or this little driver board already set up and built. But I just don't think it's going to be able to put out the amount of current that I'd want to work with. I'm sure it's. These MOSFETs that are on here, I looked them up, and they're designed to handle 10 amps at 400 volts. So You know, I could certainly do that, but I doubt that the rest of these parts in here are rated at that. This is just a cheapo little driver for a little demonstration module, so I don't think it's going to be very beefy. But yeah, it was worth the effort. It is still kind of cool to just play around with. You know, it certainly wouldn't be as lethal as a as a a nice big flyback anyway. So it might be fun to just package this up and have this lead coming out. Just maybe have it for fun, like I don't know, just popping small components or something. I don't know. Maybe find something to do with it. Thanks. So I just thought for the heck of it, I'd put the scope across this, the output from this little driver board here, just to see what what I assume changes. It sounded like it was changing the frequency. That little potentiometer. I heard a distinct rise and decrease in frequency when I played with that. So I thought I'd go ahead and take a look with the scope and see if that does indeed change the frequency of the output. So let me go ahead and turn this on. And let me dial in scope till I see a signal. Oh, that's kind of cool. Can't really see it on the camera, but that's a neat little pattern there. There we go, that's a little better. So let me go ahead and zoom that in one more, and then increase the time base so I can actually measure that signal. So let me go ahead and set up the delta measurement here. I'm going to go ahead and set that there, ref line, and then I'll move the delta line down to, it looks like about 12.5, maybe 13 kilohertz. Yeah, it looks like about 12.8-ish kilohertz there. So let me go ahead and twiddle this potentiometer. And see if it changes the frequency. Yeah, turning it down, it increases the frequency. At its lowest setting, that is about 11 odd kilohertz. Yeah, just about 11 kilohertz. And then at its top range comes down to just about, or it goes up to just about 14 kilohertz. So yeah, and that's an interesting, there's an interesting resonance in there. I'm assuming that may be a, yeah, it looks like that's a, maybe a harmonic on that. And that harmonic looks to be at about about 1.2 megahertz or so. That's, yeah. Center that. Yeah, it's about 1.1, 1.2 megahertz, roughly. And that's, let me measure the voltage of this peak. It's about 275 millivolts peak to peak that we're getting there. So yeah, it's kind of interesting. It's actually, yeah, it's actually a pretty low voltage. That would be why I'm not getting very much out of this, out of the flyback that was connected to this. This is definitely a, you know, a tiny output circuit. So yeah, I'll just have to probably build myself a proper ZVS driver. I've got most of the parts for that. I need to get a couple of the right value resistors. I probably could use these MOSFETs, although the couple of the specs are not necessarily ideal. So I could certainly test it with these, but I'd need to get some better quality ones for a more permanent solution. Yeah, and you can even tell the tiny size of these capacitors here are, that's pretty small, so yeah, that's not really going to provide much capacitance. So yeah, it's a fun little circuit to play around with, but I'll definitely need to build myself a good ZVS driver if I want to really play around with these. I've got another older, larger flyback in here that I'd probably end up using if I really wanted to get around to this and wrap a couple turns around this, make a new primary. I don't know. I may play around with that in the future, but yeah, just thought it'd be fun to measure the frequencies coming out of this and see what was going on. Thanks for watching.